Good morning. How are we all this morning after the slight surreality of the dinner last night? So good morning to the Friday morning plenary session of RIPE 85 as we head towards the end of the meeting. Hopefully a very successful one for you all. I am Brian Nisbet, and along with Fernando, we shall be chairing this session. And first up, we have a talk on Unbiasing Internet Measurements, the findings of the AI for NetMon project from Pavlos Sermpezis. Yes, hello.
Hello, good morning, everyone. So I'm Pavlos Sermpezis. I'm a researcher from the Aristotle University of Thessaloniki. And today I'm going to talk to you about a project that we have, which is called AI for NetMon. And its topic is on how to unbias the internet measurement platforms like RIPE-RIS, RIPE Atlas, Routeviews, etc. So the project was funded by RIPE NCC and the RASI, the academic program funding, the last year. And the work was mainly conducted by our lab, the Data and Web Science Lab. But I would like to give special thanks to my collaborators, Emil from RIPE NCC and Lars Brenn from MBI. You can find a lot of information about the project and our code, etc. on the links there. But I'll have some more links in the presentation. So what is the AI for NetMon project about? We had two goals. The first goal was to find if there is bias in the internet measurement platforms and how much bias there is there. And the second goal is to reduce this bias. So with respect to the first goal, in this talk, I'll first give you a brief introduction about the concept of bias, what is bias and why it exists, and give you some main results about the bias that measurement platforms have. And I will present you some online tools we have built within our project. However, you can find more material and more information in our previous talk, in the previous RIPE meeting, or you can listen to our podcast at RIPE Labs or our article there. With respect to the second goal about how to unbias internet measurement platforms, we try to do it following two approaches, either by carefully selecting subset of vantage points or by recommending where to deploy more vantage points. And in this talk, I will present you some main results from what we can find and some online tools that you can use and play with. But also, there have been two very nice presentations yesterday at the MAT working group that are in related topics on how to select vantage points. So I definitely recommend you to check these talks as well. So let's go to our first talk. How to quantify bias in internet measurement platforms. And why? At first, we think that the internet measurement platforms, RIPE-RIS, RIPE Atlas, Routeviews, give us a view in the internet. So they are like a window to the internet. We see routing things that we cannot see in our network, and we use these vantage points to measure the internet. However, in practice, the window they give us to the internet, it's not exactly like this, but it's mostly like a stained glass window. And why is that? Because we don't have vantage points everywhere. So some parts we can see them, some parts we cannot see them, and some parts we can see them better than others. So they are behind the other colors. And a couple of examples is first location bias. We'll all know that RIPE Atlas probes are mostly, there are a lot of RIPE Atlas probes in Europe, and there are less in other continents, and this is location bias. And the different type of bias is topology bias. It's in the route collector projects because their peers tend to be networks that have a lot of peering connections. And this is because the route collector projects are mostly focused on IXPs. So there is some topological bias there. And in fact, there are many dimensions of bias one can think of. We have considered several of them, like location bias, network size bias, topology, connectivity, or network type bias. For each of these dimensions, we calculated how biased the infrastructure is. So we found a metric, the bias score, which is a metric that takes value from 0, which means no bias, to 1, very high bias. And in this plot, we present the bias across all dimensions. So let me explain a bit this plot. Every radius of this plot corresponds to different dimensions of bias. You can see its location, network size, topology, etc. The colored lines and areas correspond to different measurement platforms. The orange one is RIPRIS, the blue one in the center, it's Atlas, and the green one, it's RoutViews. So when we have high bias, the line is far from the center. In terms of location, for example, you can see that the line is at 0.2, so we have 0.2 bias. If at some dimension we are close to the center, it means we have less bias. And there are different observations you can make here. You can check our previous talk, or some main findings are that the route collector projects are more biased than RIPE Atlas, and especially in terms of topology. So this plot I have shown you, we provided online in this observable notebook. You can go and play and check by yourself and check it in detail. And what you can see here, you can see again the same lines, the same curves of RIPE Atlas and RIPRIS. And what you can also do is put your own list of ASNs. So for example, you select some RIPE Atlas probes and you want to check how biased this set is. And you put the list of ASNs there, and it draws you a line for your set. Or you have a custom measurement system and you want to see how biased it is, you can do it. Or even you can do it for a list of networks that are not measurement platforms. So for example, an idea is that if we would like to check how biased the networks are that are ranked higher in Manders, is there bias there? Are the large networks, the small networks, is there location bias there? You can try it with any set of networks. It doesn't have to be measurement platform. And also you can have different other options. So for example, you can select the dimensions of bias that you would like to see, because maybe not all of dimensions may be of your interest. And on top of this, we have created an API to make things easier for you. So you can do a GET request to this API and get the bias score for internet measurement platforms, Atlas, RIS, RouteViews, and the route collectors of RIPRIS individually, or your custom set. I have here some examples so you can see how to poke the API. And what the API gives you back, it gives you a JSON with the bias dimension and the values of the bias score of this set along these dimensions. Now, just a final thing, just be gentle with our API because it's really alpha version. So if you encounter any problems or you have some suggestions, please reach us and stay tuned. We are going to improve it in the following period. Now, let's move to our second goal, how to unbias internet measurement platforms. And we said we can do this either by selecting subsets of the vantage points, which we call subsampling, or by extending the infrastructure. Let's go first with subsampling. What does this plot shows? On the x-axis is the number of RIPE Atlas probes we select. On the y-axis is the bias score. The lower, the better, because we have less bias. So if you see the green line in the middle, it's some experiments where we selected randomly some RIPE Atlas probes. And as we can see, the more probes we have, the less bias we get. On the top line, with the markers, we can see what is the bias when we ask the RIPE Atlas interface to allocate to us monitors as with the automatic algorithm. And we observe that the bias is higher there. Probably this is because there is some load balancing algorithm in there. So a first step to do is just select randomly yourself. But still, this is not enough, and you can do some things better. We'll show you later. Here, it's the bias for RIPRIS route collectors. We have a plot. Each dot corresponds to a route collector. On the y-axis, we have the bias score again. the lower the better. On the x-axis is the number of peering ASNs each route collector has. What we can observe here is that having more peers does not necessarily mean lower bias. We can see some route collectors with many peers that have higher bias than other route collectors with 20 peers, let's say. However, an important observation is that route collectors that are multi-hop, they are less biased. And this is because they get access to more diverse set of networks. So now how to unbias measurements? We have designed a heuristic subsampling algorithm and we tested it. And I won't get into details. You can check the documentation. I have all the details about the algorithm and how we checked it. But I'll just want to state a couple of main findings. We found that by carefully selecting 50 peers from RIPREs, from different route collectors, a good set, let's say, of 50 peers, can decrease the bias of the entire RIPREs by 4 times. So there is room for improvement. And the same holds for RIPE Atlas. With 300 probes carefully selected with our algorithms, we managed to have almost 0 bias. So there is indeed room for improvement there. Now, the second approach. Let's deploy extra vantage points to decrease the bias of the measurement platforms. We calculated for each ASN, if we added it in the infrastructure, in RIPE Atlas or RIPREs, how much the bias would decrease. And the more it decreases, the better, the higher is ranked this ASN. And based on this metric, we provide some recommendations. We have 2 online tools that you can go and check and play with the data. So we present a rank list, and this is by taking into account all ASNs. However, you may want to parameterize this list. We just didn't want to give you just a sorted list without further explanations. So what you can do here is you can filter this list and select, for example, networks in a given region or a given country, or networks that have a customer count larger than X, or networks that are connected to IXPs or are in peering DB. So you can do a lot of filtering options based on what are the criteria or the cost of adding an ASN in the infrastructure, and you still see the ranked list after this filtering. And another thing we calculated, and you can find in this online tool, is that when we deploy extra vantage points, we don't have only in mind the bias criteria. We also have how much they improve our visibility of the internet. So the bias, it's not our only objective. So in this plot, it's interactive plot in the online tool. We see on the x-axis how much bias is decreased by adding an ASN. Each dot corresponds to an ASN. Values on the left means that we decrease a lot bias. On the y-axis, it's our improvement metric. We calculated an improvement metric on how closer to the edge of the internet we will be. So the higher the y-axis, the better. The best option would be to be in values on the left in the x-axis and on the top on the y-axis. We see that there are not that many networks there, but still we can see there are different trade-offs, and we can still select vantage points that both reduce bias and at the same time can improve our view of the internet, the completeness of what we see. So, summarizing what we have done in the AI for Network project. First, we quantified the bias, and we believe this is a very important finding, because in this way we can raise awareness about the issue of bias. There are some expert users that may have thought of bias or were aware of, but may have not thought of all dimensions, and maybe there are some other not so expert users that may have not considered this. So what we suggest you is, when you do some measurements, always take into account that there is bias, going to our tools, you can check what types of bias you have, and this hopefully can help you to better interpret your results, to not get into wrong generalizations or some pitfalls. With respect to the second goal on unbiasing the platforms, our analysis have shown that there is a lot of room for improvement. Hopefully, the recommendations we do, it's a first step towards reducing bias. So for example, if you see outside, there is a board where with the most wanted ASNs for RIPE Atlas. We have already contacted the guys so they can take into account our findings in order to find other most wanted ASNs that could reduce bias. And I think that's really promising because some other people have started working on this. It's on the MAT working group that I mentioned before. And hopefully in the next period, some of us, our group or their groups, will have some solid results about how to decrease bias in our measurements, in our infrastructure. And yeah, that would be good for the community. And with this, I would like to thank you. And I would like to ask you if you have any feedback, positive or negative, or any inquiries or any suggestion, etc. Yeah, contact us or have a question here now. And yeah, thank you.
Thank you. Is there any question for Pavlos? Please state your name and affiliation.
Hi, Jeff Houston, APNIC.
Hello.
I'm still left with a number of kind of dangling questions here. And I don't understand, I think, what you believe is not biased. And there are so many ways in the internet to think about what is unbiased. If I'm talking about averages, then the average user is probably Chinese or maybe Indian. And if I take those two together, that's sort of 40% of the user population. And it has no Atlas probe. So Atlas is beyond all hope in getting an unbiased view, if that's your target. Or are you trying to say that every single one of those 70,000 ASs, 75,000, is equal to every other? And again, that's not really true because 65,000 are stubs with one or two people in it, you know, the other are large. So what do you define as not biased? Okay. And why? Oh, and the other thing too, 90% of all users use these odd little things called mobile phones. And as far as I'm aware, there's no Atlas probe near it. So again, is Atlas hopelessly biased because it has nothing to do with average user behavior?
Yeah.
So I said, I'm just left dangling behind this going, what's your 0 point? What's unbiased for you?
Okay, great. That's a really nice question that hopefully I can give you more insights on this. So starting from your second question, yeah, RIPE Atlas is hopefully, yeah, it cannot get a representative in terms of network type because we will always have this thing that it cannot cover mobile phones. And so RIPE Atlas will always have a bias in this dimension of network type, but maybe in other dimensions we don't have. And now let's get back to what is representative. What is unbiased? Unbiased is to be representative. So indeed, the average, let's say, internet user is in China. So the good with the measurement infrastructure is that it doesn't have only one vantage point. So we don't talk about only the average guy. But if we have 10 networks in China and one in Serbia, or no, if we have 100 networks in China and 10 in Serbia, and we have 11 probes, we should put, or for an unbiased result, we should put 10 and 1. So it's representative.
Why don't you just weight the results by the degree that you need extra weight on some measurements? So if I've only got one probe in China and 500 in the US, and I want to talk about the average across the two, why don't I either divide the US numbers by 500 or multiply the one Chinese number by 500 to get them ranked up? Why do I need more probes? Why don't I just weight the numbers?
You can do, you can weight the numbers. So our framework is quite generic. So we did the first approach in the bias score, in the way we calculate the bias score, you can do a lot of things. I mean, we can parameterize it. And one thing that we don't know and we need to know is how exactly we should parameterize it in order to get the optimal results. And maybe the parameterization and the optimality may be different for different use cases. You want to measure that thing, you may need to do a different parameterization. For this thing, you have to do something different. But yeah, this is more complex, and it's one of the research directions we are thinking, because that's only the first step.
The takeaway I get, and I'll set it down, is that unbiased actually depends on what you're trying to measure. It's not an abstract fact independent of what you're trying to measure.
Exactly.
That's what I'm taking away.
Exactly.
That's
why in our online tools, we try to do as much parameterization as possible, so you can go and play with the results depending on the use cases, because there are hundreds of use cases. We cannot cover all of them.
Thank you.
Hello, Kostas Zorbadelos, CANAL plus Telecom. It was natural that Geoff would partially cover my question. So my question had to do, you use a bias metric between 0 and 1. Can you share, or do you have documented anywhere the exact algorithm of how exactly you calculate that?
Yeah, it's in our README docs.
Thank you.
So yeah, even for the statisticians will understand directly, it's a Kullback-Leibler divergence. All the other guys just think that it's between 0 and 1.
Hi, Guy Mayer. I'm a developer on the Atlas team. I'm wondering if you have a minimum and a maximum number of probes, number in an AS, in order for it to be considered represented. So is one probe enough? And then in the other verse, is 100 probes too many? So what is the range in order of representation for probes?
We didn't look at this. So we consider that if an AS has at least one probe, it's covered. We know it's wrong, or for some cases it can be wrong. But in our initial investigation, we wanted to consider as much dimensions as possible. And because all these dimensions, the data we have for these dimensions are available at an AS granularity. We don't have smaller granularity, how ASNs are split within the intra topology. That's why we started with at the AS granularity. So we considered each network having a probe, it's covered.
Thank you.
Okay, thank you. There's no question. No. Okay, thank you, Pavlos.
Thank you.
Interesting. Okay, next presentation, Konstantinos. Kostas, sorry. Automated Interface Traffic Engineering. Thank you.
Hello, everyone. It's always a pleasure to be here. So I'm Kostas Zorbadelos, working as a lead network architect in CANAL plus Telecom. And this is a presentation about a practical network automation tool. So from the academic presentation of Pavlos, we will go to something very practical. So hopefully this will be interesting to you. How exactly is this supposed to work? Okay, found it. Come on. Yes, perfect. So more or less the outline of the presentation. First of all, of course, we need to have a problem that we're trying to solve here. Then we will describe, according to the problem, what are our design goals, what were our design goals with the tool. Then we will give a presentation and an actual pointers to the tool, which is open source. And then we will switch a bit the discussion to some operational considerations what are actually issues or not by using such an automated way in traffic engineering. So what is the problem here? Suppose you have an IP network with multiple points of presence. It's geographically dispersed, many POPs, transit providers, peers, internet exchanges, private interconnections, whatever. Of course, you also have, in these cases, varying costs in transit capacity. Submarine capacity might also be involved. And as we all know, in traditional ISP networks, it is actually inbound traffic that is dominant in the network. So we need to have a way to optimize the incoming traffic streams and distribute them among available capacity. That's number one, optimization in economics, we would say. But on the other hand, we also have emergency situations. We have situations when we need to divert traffic. This is, first of all, a security incident, a DDoS attack, where we need to immediately do an action, or we could have a failure. Before my current role, I had very little to no experience about submarine cables. I thought they were pretty stable. Oh boy, do they break. That's the thing. So this is more or less how the CANAL plus Telecom network looks like. We're a small company, but we serve the French overseas territories. And as such, the network is, I would say, global. From La Réunion, a small island in the Indian Ocean, all the way to the Caribbean, the very nice French islands over there, and French Guiana. We need to cover all of that. So we have POPs in various locations, plus a lot of PNIs and transits. We have done our best to document our network in PeeringDB, of course, as good citizens. So you can see we have various transit providers in various locations. So, and plus a lot of presence in various internet exchanges to accommodate that. So a very small company, I consider it a very interesting network in general. So what were the design goals of introducing traffic engineering in our inbound traffic with an automated way? So the main point is that manual configuration on the routers is very cumbersome. Especially if you manually configure the network, you will definitely have inconsistencies in configuration here and there. So the whole operation generally is error prone. On the other hand, there might be a lot of routers that are involved in an incident. You might need to do an action to many routers at a time. So real-time reaction, let's say, is not possible if you do it manually. So we would need a tool where the configuration could be performed by network operators, but in an easy way. Or it could also give an API or an automated way for a program without human intervention to do the traffic engineering. And ideally, the tool should be network vendor neutral, because in many networks, there are a lot of vendors involved. So we need to do the traffic engineering quickly in general, do it reliably, do it without any errors, optimize our economics, and provide some automation mechanism to react real time in extreme cases of failure, either security incidents or failures in cables or whatever else. So here is what the automated tool does and how it looks like. Of course, we're talking about BGP here because BGP is the only exterior protocol out there. It is, of course, already used extensively for traffic engineering using various tricks. Others, they would call it hacks or whatever. And the tool's purpose is to automate the BGP announcements of a network to various peers, and this affects how traffic flows inbound. So our solution, the design, there is a central configuration point. There are some sources of truth. The sources of truth are actually databases. It's a very nice fancy term to use instead of databases. So they represent the intended state of the network, how our peerings and our announcements look like. And out of these sources of truth, the tool generates a standardized BGP policy configuration. And we're talking especially about the outbound policy in this context here. The idea is that we tag the prefixes we announce with BGP communities, and this tagging affects the policy. So the only thing an operator needs to do is to actually think what kind of tags needs to put in a prefix, tag it accordingly, and enforce the state. And hopefully the tool gives all the necessary flexibility to do the traffic engineering tricks operators do. So we based our design we tried to use standards as much as possible. So in terms of tagging, of community tagging, we utilized the BGP large communities. Large communities is a rather recent, we would say within quotes, but okay, 2017 RFC. And it gives you functionality to express policies with 32-bit ASNs. A large community is actually a 4-byte integer that looks like the community I have in the slide. It overcomes the policy limitations that you would have with 32-bit ASNs. And then very nice thing that is that together with RFC 8092 that defines the BGP large community attribute, there is a pairing RFC 8195 that gives some very nice examples of policies of how you could utilize large communities to design policies in your network. So we actually have an ITF-based way to create policies. We utilized that in the design of our tool. So according to this informational RFC, the second number inside the BGP large community is actually a function identifier. And generally speaking, communities are split to two different categories. You have either informational communities, where, for example, you tag a route depending on its type, if it is a transit route, a peering route, whatever, where you learn it from, the geolocation that you learn it from. All of that is actually tags that give us some information about the route. And then you can have also action communities. So by defining, for example, here, this community with 40 as a function identifier, you can express the policy of do not announce a route to a specific peer. So the supported traffic engineering actions in the tool are actually actions depending on an individual peer or a geographic location. So you can choose to announce or not announce a prefix to a peer, prepend it 1, 2, n times, or do the same thing in an entire location. Either choose to not announce a prefix in a location or announce it, prepend it, whatever. All the tricks that the operators do. What do we use as sources of truth in the automation tool? Very well-known open source tools. We use netbooks as our IPAM system. So this actually holds our prefixes, and in there we have our BGP announcements. So all the announcements plus their tagging with large communities are in there. And then we utilize Peering Manager to document all our peerings, all our eBGP peerings with third parties, either PNIs, internet exchanges, transits, whatever. Now, as I mentioned, the purpose of the tool is to get the intended state out of the sources of truth and generate the necessary configuration for the routers. So configuration regarding the BGP announcements and the outbound BGP policies, and then force it on the routers. We have, again, a bunch of very nice tools, open source tools in this area. We chose what we think is a combination that is used from a lot of other players as well. So the whole thing is based around Python. It's Python-centric. We use Napalm, the open source library, to configure the routers, plus Jinja templates. And we use as the main configuration management engine, Salt, which provides a lot of very interesting features. So the development was actually based on these open source tools. There is a GitHub repository. I spent a lot of time trying to document what I need. So it is published on GitHub. This repository actually provides a simulation, a network simulation, and we're talking here about an actual vendor IP network. So it is not, let's say, some sort of academic tool. We try to simulate a production IP network as close as possible to reality. We use Docker containers for that, and Docker Compose, and we utilize GoBGP as BGP peers in our topology to be able to test the tool. The current implementation of the tool supports currently only Juniper routers, but hopefully the ideas of the tool are general enough so that can be ported to other vendors as well. And especially if you can contribute and provide extra vendor support, that would be highly welcome, of course. Now, this is how the tool looks like from a user's perspective, let's say. We document all our peerings on PeeringDB in a web interface. We go to the IPAM system and we tag specifically the announcement we're interested in with specific large communities. And then with one command, we apply the state to the network and magic happens, hopefully without errors. How did the production network roll out did? Because we currently are using this tool in our production network. There was a gradual deployment inside our AES. So we did it router by router and location by location, which was nice, which was very controlled in general. Up until now, generally the deployment was smooth. And the tool currently handles our 260 peerings in 6 diverse geolocation and the 6 internet exchanges we peer. Hopefully it can scale to much bigger numbers. Generally speaking, I consider our network rather small to average compared to big networks out there. The experience, so the implementation, I wouldn't say it had great difficulties. Most of the time was spent in design, thinking what are the needs, trying to accommodate in the design on possible cases, be flexible enough and stuff like that. So 90% of the time was actually low-level details thinking, plus preparing the network in order to introduce the tool. Of course, the operations now require a paradigm shift, as in all automation cases. Now, having an automated tool is a very nice thing in general, but there is also the other side of the coin. There are some considerations in operating your BGP announcements in an automated way. So what are these considerations? In general, I think all or most of the participants in here are good manners citizens on the internet. They appreciate security. They appreciate the clear documentation of route policies, contacts, and all of that should be documented in IRR databases in general. But what do we do about on-demand announcements? If you need to react to an event and your entire address space, you need to do an action in a very specific portion of your address space. What do? Do you pre-provision everything in IRR? All routes, all possible route and route 6 objects? this is not practical most of the times. And of course, if you try to update the IRR on the time you need it, it's too late. You might have, you're not agile enough to be able to respond to incidents. And on top of that, we have the next generation IRR. We have the RPKI with its ROAS, which is another source, of course, of validation. Now, there is a very nice attribute, or not so nice, as we can see inside ROAS. It is the max length attribute. And max length attribute can give us the necessary flexibility for traffic engineering. But as in all things in life, nothing comes for free. There are security implications with using too flexible ROAS, let's say. You are susceptible to what is called the forged origin prefix or sub-prefix hijack. And there is a very nice RFC, a very nice informational RFC that got its number, if I'm not mistaken, within this week. So I had to adapt a bit the presentation. It used to be a draft at the point where I was writing the presentation, but now it is it got its number, and it is a best current practice document. So it actually gives a discussion and an overview of what are the implications of using the max length attribute in ROAS. And of course, this kind of forged origin prefix or sub-prefix hijacks cause greater harm for non-announced address space. And the general idea and the recommendation out of this is that you should use minimal ROAS, and your ROAS should reflect the current operation state of your BGP announcements. Very nice in general. What are our experiences with the transit providers, since we use many in various different locations? Now, of course, all respected transit providers care about security, but they also have varying degrees of flexibility. So there are providers where you need to do complete manual communication in each and every case where you need to do a traffic engineering action, all the way to others that provide you with the ability to announce more specifics or do it on demand, whatever. And there are others in between where they generate their filters automatically, but not real time, let's say. It is an action that they do a few times per day or whatever. From our side as customers, of course, we require the greatest possible flexibility. We want to have the ability and the control to do whatever we want with our announcements. So we need to find a way in between. Now, whatever automation mechanism you use, of course, a very big thing is that you need to monitor your BGP announcements, and you need to monitor how your announcements look like from the outside, from the internet, and ideally also how your announcements are configured to your routers. So for the first case, there are various services out there, free. We all know and love RIS Live, let's say. And for number two, the best option is the BMP protocol, and especially its variation about adjacent reboot. This BMP protocol is very nicely supported in at least one open source tool that I know of, the very nice PMA-CCT tool. And theoretically, if you monitor your announcements as seen from the outside and as configured on your routers, you should be able to notice differences, create alerts, and all that stuff, and be able to work. For us, it is currently a work in progress. We work together with very nice people behind Artemis. They have now a company called Code BGP, but there are also very nice open source solutions out there. There is BGP Alerter, a tool that can also provide monitoring and alerting real time. So this is all currently work in progress for us. Now, which brings me to my last slide and the discussion points. Okay, we know the security implications in RPKI ROAR max length. but what do we do if we actually need flexibility and operation agility? Is actually this hijack attack, which, by the way, RPKI was not designed to address this type of attack specifically. Is it a blocking point? Should we just create very, very strict ROAs and lose all the ability? Should we have very flexible ROAs and be agile? I think personally that the solution is somewhere in between, as always, except from security incidents, because in security incidents, you never know where you will be attacked. So in there, I think there is a point for discussion, to say the least. So I don't know if any best practices out there for operators and transit providers, specifically on how to address the dynamic and on-demand announcement issue. But of course, we are here to discuss. Hopefully, this is an interesting point for discussion, and something good would come out of it, best current practices document or whatever. And with this, I managed to do it and leave 3 minutes for questions. I'm really sorry. Thank you very much.
Cool. Thank you very much. Apparently, someone running to the mic to ask a question. Please.
Hi, Kostas, Pavlos from UNBIasing. So, very, very interesting. Thank you for sharing. And sorry for my voice, it's from yesterday. Okay, so your solution is heavily based on BGP communities and mostly on large communities, which is nice. I would like to ask you about your experience after rolling out this solution, because from my experience, looks like not so many people always honor the community. So you have expectations, but sometimes this doesn't work. So have you rolled it out? Have you tested it in real life? Have you seen people honoring the communities and doing what they promised?
Okay, thank you. Thank you, first of all, for being here after a rough night. So the thing is that this thing affects your outbound announcements. So all you need to do is have support for large communities in your own network, not to other third parties. And to be honest, the approach we currently use is that these communities have semantics inside our AS, and we delete it and we clean it to our announcements. So we just enforce the policy internally. The communities help the tool to do the right thing in the announcements, but on the outside, these communities do not appear. This is something that is internal to our AS.
Okay, so they don't go to the transit
to the
provider,
peer. Yes,
yes.
Yes.
They don't go over there.
They don't go there.
So it's just a signal inside,
Yes.
and then you either stop the announcement or you do it more specific.
Correct.
Depends on.
Actually, you can actually prepend or not announce, and
Okay.
prepend either to one peer or to an entire location, etc., etc.
Okay.
For example, if I want, let's say, on demand to stop my announcements in a specific location, to the US, for example, with just one tagging and one CLI command, I can enforce that.
Okay, clear.
That's
Thank
the
you.
idea.
Looks like. Please.
Hello, morning. Alexander Azimov, Yandex. Thank you for this fascinating talk. And I just have a comment for your question, or comment about max length. So it's BCP. It's just a suggestion.
Yeah, of course.
And of course, you have a trade-off: forged prefix that we have never seen, and
Yeah.
flexibility. And it's up to you what you choose. So you have chosen to the flexibility, as far as I understand. For my network, it's also true, and it's fine.
Excellent. Thank you so much. Yes.
Please.
I think, just to complement a bit this, currently my ROAs are too flexible, and I think there is some room for improvement there. But as you say, I totally agree. It's a trade-off. Yes.
Please.
Hi, Leandro Bertoldo, University of Twente. One question, because, okay, you can use communities and prepend and everything to control where are you receiving the prefixes. But so you have a lot of different possibilities in a case of when you lost a link, for example. Do you have some manner to forecast the impact of one policy or another?
Very nice question. Thank you. I think this has to do with your monitoring plus capacity planning tools, whatever you have. So I guess this is a discussion for NetFlow, a lot of NetFlow, and whether you can have simulated tools to show you how traffic will flow differently. Ideally, you could have such tools and you have pre-calculated the scenario in advance for various failures, and then be ready on the point of failure, let's say, to apply the correct policy. Very interesting.
Yeah, the question is,
if we have such
yes.
No, we don't. But generally speaking, our network, I would say, is rather simple. Our capacities, our submarine capacities in the areas we serve are very scarce, so we don't have a lot of options. If a cable breaks here, there is only one or two other alternatives, nothing else. So we just try and see on demand. But from previous failures, we know more or less what we can do and where is the limit of what we can do with our capacities.
Okay, thank you.
Thank you.
Cool. Please.
Okay, Rüdiger Volk, Kostas, great stuff. I'm kind of regretting that we didn't cooperate in our previous affiliations. Well, for the MaxLink stuff, I would like to say, oh, I'm really happy to see someone finding good use of it. And for the dangers, actually, the dangers are, one could kind of think that any ROA that is in the RPKI system that is not backed up by an actual route as an invitation for someone to attack. And whether that is because of many routes or many prefixes generated via max length, or it is some carelessness offering something else. The max length thing, well, okay, maybe a little bit more interesting. Next topic, the communities. I remember the times when people were bothering me because my network did not provide external communities, quite obviously, and in particular with the large communities available. There is plenty of room of doing the information and action communities also for outside. An interesting question there is how to communicate your signaling system. And I guess we will discuss what has been done on that offline. And well, okay, I stopped with that. Thanks.
Yeah. Thank you for the observations. Well, the most important, this kind of communities, of course, we use it, as I said, internally in our network, and our customers can also use it. The best way to communicate them is properly document them somewhere in a public location.
Okay, and on that note, thank you very much.
Thank you.
I can find the mouse on this. No, apparently I can't. My laptop has just decided it doesn't like mice. So our next, for the first lightning talk of this morning is on, so it's the internet in Ukraine, 200 days of resistance. Unfortunately, the planned speaker, Svitlana Tkachenko, cannot join us this morning, but wonderfully, Oksana has agreed to speak on their behalf. So thank you very much.
Hello all, I am really extremely sorry for Svitlana. He suddenly met problems with the health. She made excellent presentation and I am sure that you have to see this presentation. I am not technical expert. I can't answer technical questions, but I will do my best to give you any impression regarding situation in Ukraine. First of all, today is 247th day of full-scale aggression against Ukraine and 8th year of war. How to use it? Excuse me. Thank you. On February 24, we awakened from bombing. It was unbelievable, but it happened. And since that, we had huge experience, very unexpected for us. Svitlana Tkachenko works at Hostmaster company. This is registry of our .ua ccTLD. I can't comment a lot of all this information, but I have to say that on December 2nd, we will celebrate 30th anniversary of .ua, and usually Hostmaster organized a very interesting conference with the most progressive information and messages and all developments. What happened with .ua after the beginning of full-scale aggression? First of all, they did their best to secure people. As far as I know, they evacuated their staff to the western part of Ukraine. They secured all information, all equipment, and they met a lot of financial problems, but as far as I know, they managed them rather well. This is pictures from our internet infrastructure. I have to say that near Kiev and near Kharkov, all internet and mobile equipment was just destroyed. For example, a sister of my very close friend lives in Bucha, and we did not communicate, we did not have any communication tools with her for 35 days. She just wrote paper notes and gave them to all of them who managed to evacuate from Bucha, and some of them called on the phone. She wrote and said that she alive. I have no what to say because I don't understand what does it mean, but maybe. It will be Kosveta's email, and maybe you can send her questions and she answer it. Before, from the beginning of full-scale aggression, we met problems with internet connection and mobile connection only on occupied territories. And huge help for us was Starlink. We received 25,000 of terminals, and this was the best way to restore immediately connection in the occupied territories. Maybe you know that Elon Musk even canceled the fee for Ukrainian representatives. Then it was some another development of situation, but now we again do not have to pay, it seems to me, for 3 months or something else fee for using Starlinks. After October 10, we met huge problems with connection on the whole Ukrainian territory because our energy infrastructure was nearly destroyed for 40% on October 10, and then on October 22 and in other days. So damage for our energy infrastructure is huge, and that is why our operators can't deliver connection. Now this is the picture of our Kyiv. Usually we have lighting, how to say, spot which is seen by a lot of kilometers from Kyiv, but now this is the picture of after our blackout. The only one decision just now is the diesel generators, and representatives of our Ukrainian generators asked everyone to help with the diesel generators. What I would like to say, it's extremely important for us users to see how Ukrainian telecom industry reacted to the full-scale aggression. For example, we have 3 mobile operators which in peaceful time fiercely competed each with other. But on March, as they launched nationwide roaming, and each user can call without any additional fee to other operators and use internet services from other operators also. Ukraine received a huge amount of help and support from international community. I know in person about the Global NOG Alliance. Thank them. Thousands of thanks to all of you and to them. And I know about smaller initiatives which are not so popularized, but it's about, I know in person, nearly about 100 initiatives which collect money, equipment from abroad and sell them to every operator, each operator, each, how to say, military division and so on. Thank you very, very much. Keep Ukraine connected. It's a very well-known initiative, and again, thank you very, very much. And please, diesel generator. And maybe some final slides. I would like to comment, be part of the global internet community. We with Svitlana Tkachenko are fellows, and we highly appreciate RIPE for not only for financial support, for building very nice itinerary for us, because all airports in Ukraine are destroyed. We need a train or buses to go from Ukraine. But even with this fantastic itinerary, we spent 5 hours on Ukraine-Poland border under shelling, and it's not easy for us to come here and to deliver to you all information regarding the situation in Ukraine. This is email of Svitlana, and if you have technical questions, please write to her, and I will be happy to answer not technical questions.
So do we have any not technical questions? We have brief time. No, I think thank you again very much for that. And so our second and last lightning talk of the session is Daniel Wagner telling us about the wonders of actually doing things with P4, I think is the exertions indeed. Thank you.
Yeah, good morning everyone. Nice to see you and so many smiling faces that early on Friday. So my name is Daniel Wagner and I'm a researcher at DE-CIX, and today I'm going to talk about, well, let's say a 2-year journey of setting up bleeding edge technology at an IXP. So first of all, what does this experience talk aim to do? It is basically here to tell you about what it took to set up the hardware and software stack of P4 switch, if you ever wondered how this looks like, and if you ever had the idea of setting up this yourself, this might be very informational for you, and especially with regard to the process itself, because there's much trouble you might avoid when you follow carefully. What does it not aim to do? I will not explain what P4 is and what it does. I will not show any implementation, nor I will show any code. I won't evaluate anything, just to show off the performance of it, what you could do with it. It's all up to you. Here's some links. Look up the source code yourself, or the evaluations. It's all there. And most importantly, I do not aim to bash the hardware vendor we had trouble with, or P4 the language itself. All right. So maybe a short motivation is, why are we looking into this? What do we do with it? Basically, P4 enables the data plane programmability, which yields with lots of advantages, but still comes with some restraints. You can build your custom protocols and solutions, especially for us at the IXP. This might make great sense. Well, you name it. Do everything you want with it, basically. All right. So what do we need to get this started? Let's find out. I will show you the whole process of all of this with this lovely timeline I set up. Just to keep basic track of the timing and how long it took things to fall into place. So somewhere in February in 2020, we started with purchasing these switches, and they got a couple of weeks later delivered. And then, coronavirus kicked in, and it was hard to get physical access to the machines. So it took quite some months until we get the power up and the first hands-on with that. Well, so now we've got those switches, and it's not like you put power on one end and packets or transceivers to the other end and everything works by itself. No, it's not the case. Like, if you fire up the switch and it's not even like showing up, it's like nothing. And so we were pretty much left without a clue how to use actually these devices, but luckily there's this help desk for us to help out. So first ticket, here we go. Hey there, I'm looking for some documentation on how to set up P4. Can you please help us? And the help desk was very responsive. I said, yeah, sure. We've got a couple scripts for you. Here we've got some zip files. Here's the link to the knowledge base. You are welcome to look this up. And you need to get some Barefoot software development environment kit from Barefoot, from another vendor. So this is like, they do the P4 things itself, and the hardware vendor we were talking to, they designed the package, the whole switch, where the Tofino switch, the P4 ASIC is living in. All right, so I did all of that. And by running the Python script, I found out on the switch that there is no Python installed in Open Networking Linux. So ONL is shipped by the hardware vendor itself, and I thought this should have a reason, right? So they shipped the switch with a particular Open Networking Linux operating system, but the switch, the scripts that they designed for it, they apparently do not run on it. So I said, I can't run your scripts. What should I do? And they said, if you don't have any special reason to use Open Networking Linux, just use Ubuntu. And in this case, I want to emphasize that it was almost literally what they said is just use Ubuntu and nothing else. No further information on that. Okay. So once again, with the timeline, I got in July all of these software pieces that I allegedly need. In August, I went ahead and tried to change the operating system that was installed on the switch, which was quite not too easy because of some reasons. It's not easy to install another operating system on a switch using a console interface, because they don't have any, like, I don't know, VGA port to look at it, what is actually happening. And before I did that, I tried to figure out what Ubuntu I have to use myself, because the help desk wasn't too informative about that. So I was looking for a compatibility list, and there was none. So I just took an Ubuntu image that I had lying around on my hard drive, and that was in Ubuntu server 18.10. And while doing this, while doing the setup of this, I found errors in the knowledge base and reported it back to the help desk, and these fixes that I provided were silently integrated into the knowledge base without any like paying me credit for that. But here we go. Then the script could run. Great. So do I now have P4? Well, I don't know. I don't know how to test this. So another support ticket. Hey, support, I found out that there is a mismatch between what your software says and what I physically have inserted into the switch. So I've got a couple of transceivers, build some topology with a couple of servers, maybe do a loop, and just see what happens. And apparently the software is reporting something completely different from what I have physically set up. So I said, there's a mismatch in your software between what I have done and what the software reports was done. So they said, okay, ports 1 to 16 are always in a ready state because of a gearbox. I've never heard of that gearbox, but it's good to know. And you might install switch abstraction layer.zip. Okay, so I installed another piece of software and I found out that helped out like nothing. And the support said, can I maybe have access? I want to see what you're doing there. So here's the timeline again. I got access for the help desk onto our switches. And after that, the company was bought by some other company. So the hardware vendor, it went into mergers and acquisitions, and the help desk became irresponsive. The Jared went offline, and the ticket was never closed. Well, okay, happens. But we have like more things to help us out because we have friends. They have the very exact same switches, same hardware vendor, and we were asking, how do you do this? And they said, oh, we have a problem that looks like that, and we said, yeah. That's exactly what we have too. Great. So any progress? No, they don't have it too. Interesting. The days passed. I mean, like really days passed. Okay. In March, I said, I don't want to wait anymore. Now let's fire up our networking department, ask these guys, can you please help us out with our particular switches? We have got problems. And a colleague of mine, he was so kind and borrowed me a light meter, light level metering device. You can like insert into the transceiver and see what is actually happening. And apparently all the ports are in reset state. Why is that? They're not supposed to be in reset state. When I fire up the software and configure it to be used, they shouldn't be in reset. So, but the transceivers, they reported like very high light meters. So I took the documentation, which is quite nice. So with the low level details, and I debugged the registers where the actual information about how the switch should use make use of all of these ports. And I found in the documentation that there's a register which is a reset negative. So this is a low active register, meaning that if it's a logical 0 in it, the reset state is enabled. And I thought like, okay, I've got the address, I've got my SPI driver, just write a 1 to the register and see if the switches are, if the ports are freed from the reset state. And reading from it yielded just whack. So that didn't happen. Okay, maybe I was too naive on that. In July, a couple of months later, a new help desk comes to life. So I went directly ahead and wrote another support ticket. Said, I was very confident in writing this. Your board support package puts all ports in reset state. The switch is unusable. Like, I was very confident with that one. And he said, okay, let me check. Took some time. Have you seen our new board support package version? Oh, great. Yes, no, I haven't. Thanks for that. I tried to install it. All the scripts are running. And apparently this board support package builds some kernel modules that are just incompatible with my kernel. Then he got more precise, asking, okay, what OS are you using? I said, I have some Ubuntu lying around. This is server 18.10. And he said, oh, have you seen our OS compatibility list? No. Okay. So I installed a Ubuntu version that was officially now compatible, which was 18.04 LTS, long-term support, with a particular kernel version, 4.18. All right, now we see the ready stats are fixed. All right, cool. The ports 1 to 16 with the gearbox are still weird. I don't use them. I go with the other ones on the switch. There are plenty of them. And loops that I configured, they actually came up, so operational and administrative up, which is great. So, okay, I have light, it apparently appears to be working. But for the links to the servers, where actually I'm doing my stuff, where injecting packets and see what happens, I remain down. The same day, I got an email from our friends who said, wow, have you seen a new board support package? It appears to be working, at least to some extent. I said, yes, I did that, I guess. Well, as the links to the server still remain down, I've got another support ticket. I said, well, they remain up, down, so operational down. Do you have any idea on what transceivers I'm supposed to use? Maybe. Have you seen our new transceiver compatibility list? Yes, thank you. And then they by themselves, once again, like they followed up on their own ticket. I said, and you might play with the layer 1 parameters on the switch. Okay, thank you. We got the right transceivers. I played around with the layer 1 parameters, and thank you. That appears to have been working. So now the link to the server is up. I then could start learn actually doing P4 code and debugging and writing, because that process is once again something to talk about, but I would like blow up the scope of this talk. And then in March 2022, we've got our proof of concept running with a simple ICMP ping. It took about 2 years. And that's a summary. All right. Now today we've got this more or less research operational, I would consider it to be, with the US Ubuntu 18.4. Here's a kernel version, the board support package that we're using with the exact versions, as well as the software development environment kit. And this switch abstraction layer, I do not use it. So maybe you want to take a photo of that combination of versions, because that is how we have it deployed today and how it actually is working. And the documentation, it was evolving while we were struggling and reporting on errors on it. And there might be a better option to right up front invest into the wedge switches, which are more used by the larger hardware vendors instead of going for the ones that we had. But this is like a graphical visualization of how it looked like in 2020. This was quite a mess. We didn't know what actually to do, just throw everything at it and see what happens. And now as we've got this running and we know what to do, things are pretty much more tidied up. So the rack itself, it now looks more nice. And the last thing is, what do we actually do with that? Is we prototyped a whole P4 pipeline for IXP solutions, and there is a recent publication at Telecom this year in Amsterdam where I've been talking about this. And well, with this information, I'm happy to conclude my talk. And if you have any questions, feel free to just stop by and drop a question. Thank you very much.
Thank you. Any questions? No? No question online also? No? Okay. Thank you.
So that's it for this session. We would remind you all to please write the talks so we get more information on what you all like. Thanks to all our speakers this morning, and the GM results will be in this room in 10 minutes or so. And then we have the closing plenary session starting at 11. So thank you all very much.
So ladies and gentlemen, can I ask you for a little bit of attention, even the group with Rudiger Falk there? No. Okay. Now in this group, stop talking. So let me continue the general meeting. I have good news for you, because based on the experience from the last result presentation, I prepared some dancing and singing performance, but luckily we have the result, so this is not necessary, so you will not suffer that. We had 4 resolutions, and let me announce you the results. So resolution number 4, which was about the redistribution of the excess contribution paid in 2022, and the will of the membership is to redistribute. So the resolution is approved. It was 1,083 yes votes, 166 no's, and 20 members abstained. Resolution number 2, which was very important in order to have the other resolutions that follows, is also approved. We had 1,014 members in favor, to 127 against, and 128 abstain. This was the amendments of the article, so the quorum was high. Resolution number 3, which is about giving the management team the authority to call for executive board elections. Just, we are not stuck in some situation where there are no people who can call the elections. And again, resolution is approved. There was 1108 members in favor, 53 against, and 108 abstain. Surprisingly, it's more than for the previous resolution, which without it, this one wouldn't carry, but you know, that's how it is. And my favorite, resolution number 4, which removes the requirement to have paper ballots. And there were 1,082 in favor, 88 against, and 99 people abstained. So with that, if I will be still a chair, you know, in next year in the Netherlands, I just declare that we will not have paper ballots in the room. And with that, I declare the general meeting closed, and I'm really looking forward to see you in Netherlands next year. Thank you very much.
Hi, this is Dmitry. Emil Košić is speaking first about Firmware system for enterprise called Replica.one. You have your own mic, so go ahead, please.
Okay, thank you. Well, first of all, it's an honor to be here to present to you. My name is Emil Košić. I'm from Croatia, a company called Sartura, and I will be presenting to you today a short overview of the Linux build systems, and at the end I will talk about the Replica.one. So the Replica.one is a open source system that we developed in-house, and that helps us to build firmware for our customers and to share it with the community. So we can now continue. Yeah. So we can start with since we are on the network conference, we can start with explaining how the Linux firmware is being built. So this is a general idea of the firmware image-based build system. So if we take a consideration of any embedded device, either used for networking or used for any embeddable purpose, there are generally a few steps that we need to follow in order to build a functioning firmware image. So obviously we're working with open source projects. So the first thing we'll need to have is either to generate a tool chain. A tool chain is a sort of a set of tools, set of compilers for building for the target platform. So if we have let's say a network switch, and we want to build a firmware image for that switch, first we would have to either work with the SoC provider, either the SoC developer, or we would have to pick one that already exists. The tool chain comes in many form factors. There are open source tool chains, there are cross-compiled tool chains, and the first step is to obtain that tool chain, and then when we have the tool chain, we can proceed and build either our own software or the open source software or the Linux kernel, maybe add in a bootloader of some sorts, and then when we compile all the packages, all the either open source packages or our custom built software in-house, and the Linux kernel and other utilities, if we choose to do so, we can integrate those into the firmware image, and then the firmware image is ready for flashing onto a network switch, for example. Well, there are some examples of firmware build systems that are used today. I'm sure all of you have heard about Yocto, for example, or Bilroot. So these are systems that are actually pretty built into the community, and they are being used as the primary open source open source sources for building firmware. However, There are many problems with them. They're good for, let's say, general purpose building. There are problems which I will mention in the next slide. There are many problems related to the compatibility issues and the existing platform compatibilities and actually the limitations of them, which we will explain next. So this is actually the image representation of the. So you can understand the last slide better. The process of making a firmware image. The Linux kernel is, let's say, the main part. So some generic Linux distribution and the Linux kernel are actually the platforms that we build on and are actually used in so much devices that I don't. There are other platforms besides Linux. However, the Linux actually is the best example why we need open source communities and why we need to actually develop and contribute to the open source at the upstream projects, especially for the embedded world. So if you see, we've mentioned before that after we generate this so-called tool chain, this tool chain is actually a set of compilers and tools. So it's actually an SDK of some sort that helps us to build further and build our own software that we either made in-house or to build other open source software that we pulled from community Git repositories or similar. The configuration is actually a pain point for many existing build systems that I mentioned. Some of them being the Yocto project, the Bake and embedded, open embedded. The configuration is the pain point and the point that where usually the development stops or slows down in this process of developing consistent firmware images for your devices, for your customers. We've explained this before. So we have the tool chain, we build the Linux kernel, and we build our packages. Either they are open source or they are our in-house built packages, like maybe some custom management systems, etc., such as my company develops, and integrate all of that into a firmware image and put it on a switch, on a router, on a cloud switch, or anything in between a wireless access point and a server even. So when we talk about the open source build system, we usually don't go much into the proprietary sphere of things. We used to use let's say indoors developed patches for the Linux kernel and then patch things that we needed on our hardware. However, we strongly discourage the use of our own build trees, on our own Git trees and the patches, because we diverge so much from the mainline, let's say Linux kernel code, that we simply can't keep up with the latest changes in the kernel, because we've diverged so much we can't go back, at least not easily go back. So one thing to note is that companies do tend to use open source build systems and then integrate their own software into it. So if you are developing a management software in-house and then you're trying to integrate that into your firmware image, so if, for example, you would have a wireless access point and you would like to incorporate your C program into the firmware, there's actually, you would have to build it yourself and then somehow incorporate it into the image. However, our open source build system circumvents that in a way that I will explain later. One thing to note here when using open source as the backbone of your firmware build system and your firmware image, you're actually benefiting from all the communities. So all the Linux distros, all the Linux packages, all the routing and switching software, you're actually benefiting because you're using well-proven code that was proven to be reliable and secure, that is developed by many people. So that is actually a well-suited backbone to build any kind of a build system and firmware image for your devices, even if those are your turbo proprietary devices, turbo proprietary hardware. It is smart to have such things as open source backbone, open source build system for your firmware. So some of the challenges I already mentioned before is, for example, diverging from the branch that you use to fork from, let's say, a Linux kernel. So if you develop your own drivers, firmware, and other software in-house, you might actually diverge from the mainline or the upstream of the kernel so much that you just have to break at some point and continue to fork something that is more mainline, more upstream, and then continue from there. That usually breaks a lot of things as your versions jump very often. That is actually the main reason why we want to keep to the open source upstream as much as possible and still develop our own value-added features, sort of like some management software and similar. Another issue with the embedded, I would say, embedded firmware world is hardware incompatibility. So how to cover as many devices as you can by using one build system and using it, let's say, in a programmable manner. So the smallest portion that you would have to consider, let's say, custom is your own software, your own in-house produced software, and everything else from the drivers, from the board support, from the firmware build system should be mainline open source, because then you ensure that you have as little possibility to make a mistake, because you're developing only your own. You're not developing I mean, you could develop your own kernel driver or kernel module, but keep everything else, keep the largest part of it open source, because this is not a team of 10 people, this is a team of thousands of people. So they're less likely to make a mistake and keep it there than your own company or your own team. As I mentioned, Linux distros are also a pain point, because many Linux distros have their own configurations and their own build flags, their own C flags, etc. So because communities like to do it their own way, of course, this is not actually a big problem, because you can keep a configuration fork in your own Git repo and just edit it as we go. But it would be nice to have also an open source version of, let's say, support for many known SoCs or boards or hardware. So we would like to benefit as much as possible from all these smart people from the open source community and use as much as their guidance as we can. So we as a company only give this added value as our own management software, our own cloud, something like that. So we leave the important things, let's call them important things, the backbone things, we leave them to the people that are in the community for over 10 years. We just have to trust them, because their support is huge, either on the boards, either on the embedded side, either on the kernel side, or the Linux custom software side. So we kind of have to we kind of have to work with them and use as much as we can from them to avoid these issues, of course. There's actually a funny story with Sartura. We're a company from Croatia. We started off by developing firmware images and supporting some wireless access points. So this is the company that was providing software for some of the known access points. We had an attempt, I would call it, to become a internet service provider. However, we needed a build platform that would be used to build firmware, one firmware build platform to build firmware for all of our devices, so switches, core routers, access points, etc. So we wanted to not diverge into having multiple build systems, but to have one build system and to use it to actually have one build system that is consistent, and that we just have to develop our own software, our own management software, and deploy it onto the devices. However, of course, we didn't go further as an ISP, obviously. We rather went in a direction of covering as most as we can in the embedded era, in the embedded world, and we went to develop a open source build system that would actually that would cover this problem that we had, but also would benefit the community and our customers for the embedded world. So our idea of this so-called turbo build system was to have everything, as I said, to have everything actually just use everything that the open source community gives you. So we use the kernel, we use the bootloaders, we use the software. So everything that is publicly available now, the only added value is our custom in-house made management systems and software. So this service-based ecosystem is actually an idea of having everything from the open source community. So all the important parts. So the kernel, the bootloader, the system software, everything you might find in a regular Linux distro. However, the added value was also sort of a, let's call it a package for our Linux distro's package manager. So we would just add our own package to the whole stack. This is where Replica.one comes in. The Replica.one is actually a pretty proudful, I would say, project of ours. It is a build system. It is open source. You can find it on our GitHub. It is a build system that incorporates Gen 2 as the backbone of the Linux distro part. However, it rather doesn't use the Gen 2's, let's say, flavor of doing things, but it uses its portage. So the portage is its packaging system. That is very interesting. I will explain it in a minute. So, as I said, Gen 2 has a pretty interesting packaging system. To you that don't know specifically, Gen 2's portage, so-called, is a packaging system. For all of you that didn't use Gen 2, for example, Gen 2 is a Linux distribution that allows you to, sort of enforces you to build everything from scratch. So to build all the system software, even the kernel and the packages in the user space, to build them yourself. So during the installation of this distro, you actually are compiling everything. So you're compiling your kernel, you're compiling your system software, you're compiling your everything that you would just apt get from a Debian repository. You have to build it your own on your machine. So this is actually a pain point for regular Linux users, because if you're running a ThinkPad laptop, you're gonna force it to its limits, because you're gonna compile for hours, especially something big like a web browser. You would have to spend hours in compiling the software. But the beauty of these packages is they have custom so-called use flags. So this portage, this Gen 2 packaging system, has a great interest in using customizable build for their packages. So, for example, what are these use flags? These use flags are very similar to C flags. So you have the make file when you're compiling something, and you choose what to compile or what not to compile into your software. So let's say, I'm sure you're all familiar with Netcat. So it's a software, it's a small Linux software that allows you, it's sort of a networking Swiss Army knife. You can send a request, you can become a server, you can send a bare bone HTTP requests, etc. So this is a sort of a low-level networking Swiss Army knife. And if you choose that you need Netcat on your router or your switch, and you choose that you, for example, you don't need IPv6, or you don't need, let's say, OpenSSL. You don't need it. You don't need the library. You don't need anything from it, because your switch only works IPv4, let's say. So these use flags actually enable you to easily sort of say, I don't want to use IPv6. I don't want to use OpenSSL. Compile the Netcat without it. So these use flags are, let's say, they're simplified C flags, so the compile flags that you would use when compiling literally everything. You would actually take advantage of those use flags, and you would just compile the things that you need. So this is the Gen 2's portage use flags in our build system. So we saw this as a perfect opportunity. Actually, the Gen 2 is not sort of, some people will agree that Gen 2 is not for desktop usage. And it's actually great in embedded world, because it allows you to compile the only things that you need. The whole community is behind you, because they develop these packages, these so-called recipes. They develop them, they tweak them, they enable them to be actually good. So you do have to make files yourself. So we saw this as a great leverage point into making an embedded build system, which is Replica.one. Some of the issues with this would be, what about the board support? What about the boards that are not supported by the Gen 2 community? Well, these are the things that are actually being done even as we speak, because there are more and more developers working on the embedded world in Gen 2. If you didn't know, Gen 2 has a pretty solid backbone in embedded world. There's a whole bunch of documentation on where to get started, etc. And the community of the Gen 2 embedded world is actually our backbone, as I said before. The portage system is actually you don't have to get the whole Gen 2 distribution. You can just use the portage and use it to leverage those delicious use flags that I mentioned before. And as always, for example, we as a company, we always try to benefit from the community, and we try to push things back to the community. For example, the board support, the efforts of making board bring-ups, or any kind of board support would be tremendously appreciated by the community, and we give that back, because we've taken so much from the Gen 2 community, for example. Replica.one is actually in production. We use it for years. We use it to build our own firmware for, let's say, a couple of years now, and it's been in production on many routers, switches, layer 3 switches. Even you can build whatever. You can build for ARM, or you can build for 8664. You can build for servers, etc. So it's a pretty versatile system actually, and I encourage you to check out the GitHub actually. So it's under Sartura Replica, and I encourage you to even contribute to our Git repo and bring up some boards. These are some of the hardware. You might recognize the Raspberry Pi. You might even recognize the EIE puzzle. So we have pretty serious customers, I would say. The upper right is a ClearFog sort of a development board. So we are into the development boards also, because it is important to have replica and to feel the replica, how it works on the bare metal. It can also work in the virtual machines, etc. But it's being used on many routers and switches today. So about the maintenance. The maintenance is, as I said in the beginning, the maintenance is done majorly by the Gentoo community and their packages and of course the Linux kernel community, but the value-added features are made by us. So our own, let's say, cloud, our own services, our own management software, etc., are added to this firmware build system, so we can build our own, so we can satisfy our own customers. For example, we have many people that are working in the company that actually support and can commit to the upstream for the Gentoo, for the Linux kernel, and for some other like OpenWRT. We have pretty interesting people working, and we repeatedly try to give back to the community as much as we took from it. So this is about everything on the replica system. I imagine you will have some questions. This is a virtual for me. I'm a firmware engineer at Sartura, so if you have any questions.
Thank you very much. We have one question on the Q&A panel, but it's not related to the presentation. So I would ask anyone who has questions to the presentation to come forward or write it to us. I have one question from Robert Scheck. It is GmbH. How do you actually ensure integrity of your firmware images and build artifacts? So how do you handle cryptographic signatures for your firmware images and or build artifacts also during runtime of the image of the device itself and verify that there's no tampering?
Yeah, this is a great question. The question is about integrity of the firmware image. The integrity of the firmware image is in replica is being made in sort of a, so the only actual signature you have to worry about is your own value-added software. So everything else is backed, let's say, by the upstream, by the communities. The only signature you have to manage is we're talking here about the reproducibility of the firmware image from one state when you compile it in this time or in 5 minutes. So we're talking about these signatures, and Replica is solving this by keeping sort of a snapshot of the current build system state and the current recipes of the Gentoo's portage system. So we keep track. We actually keep track of this internally with our customers, because there's no point of having it, because the firmware image at the end is sort of a proprietary binary blob, because it is used on the switches and routers that I showed you. So the reproducibility is only a concern of our customers, and we do that by sharing the snapshot and the recipes of the build system.
Thank you. So do we have any other questions regarding this presentation? I don't think so. So thank you very much.
Thank you all.
Give me just a sec because we have one question and there was, I think this person is really interested in this. Maybe that goes a little bit in the direction of the chair team, if they could. Thank you. Raza Kazim is asking, how can we join on site? We want to join the meeting on site, but there is no Serbian embassy in our country or in the nearest country. Can you help us? I would say the next meeting is not going to be in Serbia, and the whole team is caring and trying to make sure that all visa requirements are met as simply as possible. And if not, reach out to the chair team. Is that? Chairs are nodding. Perfect. Okay, so let's continue with the plenary program. The next presentation is by Peter Hinrich from SURF, and he will talk to us about the quantum future. Enjoy.
Good morning, everyone. My name is Peter Hinrich. I work at the Innovation Department of SURF. SURF is a partner in the Quantum Internet Alliance. I'm a team lead of the use cases team in the Quantum Internet Alliance, and therefore I'm very grateful to have the opportunity today to tell about our plans and ambitions to build a quantum internet in Europe. A little bit about SURF. SURF is a cooperative. It's the collaborative organization for IT in Dutch research and education. Our members are universities, universities of applied sciences, academic medical centers, research institutes, and secondary vocational institutes. Our activities include areas such as high-performance computing, data storage and management, security and identity services, and of course our network. We operate our own network in the Netherlands with over 12,000 kilometers of fiber and 360 locations. So SURF is a partner in the Quantum Internet Alliance. Our innovations we do with our members, but also in European projects such as the Quantum Internet Alliance. The Quantum Internet Alliance consists of 40 partners in Europe out of 8 countries, coming from both industry and academia. Together, we have the moonshot ambition to build a quantum internet in Europe in the next 7 years. And for that, we received funding from the European Quantum Flagship. And only a couple of weeks ago, we had our kickoff, so we are about to start off with our work. So the objective of the project is to build a prototype for a fully programmable quantum network, connecting 2 metropolitan scale networks by a long distance fiber using quantum repeaters. Before I go further with that, I will tell a little bit about the basics of quantum communication. And in a quantum network, information is sent in the form of qubits. And many of you may already know what a qubit is. It's the quantum mechanical analog of a classical bit. And whereas a classical bit can have either the discrete values 1 or 0, a quantum bit can be in the superposition of both the states 1 and 0 at the same time. However, if we can perform a measurement on its state, the superposition is disturbed and you only measure the values 1 or 0. An interesting feature of qubit is that they can become entangled. And what it means, if 2 qubits are entangled, the outcome of a measurement on its value of their values are correlated, even if those qubits are separated by a long distance. And importantly for quantum communication or networking is another phenomenon, and we call it entanglement swapping. If you have multiple sets of qubits in entangled states, we can swap the entanglement and create entanglement between other qubits. And let me explain this in an example. If we would have 3 independent nodes, let's say Alice, Bob, and Charlie, and there is a direct link between Alice and Bob, and there is a direct link between Bob and Charlie, but no link between Alice and Charlie, we can first create entanglement between Alice and Bob. Then we can create entanglement between Charlie and a second qubit on Bob. We now have 2 pairs of entangled qubits. And by swapping the entanglement of these qubits, we can create an entanglement between Alice and Charlie, even without a direct link between them. Now, this has been shown in the laboratory in Delft, between 2 laboratories on the campus there in March 2021. So now back to the objectives of the Quantum Internet Alliance. In order to build this network, we of course need these repeaters, quantum repeaters, by the principle I just explained, but we also need other hardware and devices such as photonic clients, hubs, and processing nodes. Well, in order, and we also have to develop a software stack to program and control this network. And in order for such a network to be usable and to fulfill a specific task, all these devices have to meet very strict parameters. And these parameters, hardware parameters, these requirements come often as a trade-off. Therefore, we have chosen two test protocols to inform the technical requirements. These are the deterministic teleportation and blind quantum computation. In these examples, you can see, for instance, the trade-off between parameters such as the rate at which entanglement is achieved and the coherence time, which is the time that entanglement stays intact. Now, to assess these parameter requirements, we can simulate and model them through our core blueprint simulation. We have a dedicated modeling and simulation team, which works closely together with the device experts and the network architectures experts. They will make the hardware models available as software modules in the core blueprint simulation, so we are able to assess these requirements. We also have an innovation and outreach team that will be responsible for to translate the technology development into future products in Europe. And they will engage, reach out to the European communities such as RIPE and others, mainly via the Quantum Internet Alliance Technology Forum. The CATF, by the way, next year in March, there will be a conference in The Hague inside quantum technology. There will also be a meeting of the CATF. So if you are interested, come to the conference in The Hague and join the CATF. Collaboration with potential users is very important because we want to take real use cases into consideration in developing the system and when having to choose when there is a trade-off between parameters. So therefore, we have a use case team consisting of community specialists, of which I am one, I hope, and application and protocol experts. We will engage and interact with potential users and identify their high-level use cases. These will then be analyzed and described in more detail. We will find matching applications and protocols, and if necessary, develop them or adapt existing protocols. When we have developed code in the software development kit in our system, we can do the simulations, and the results of these will be validated again with potential users in order to improve them and understand better what the relation is between the user requirements and the hardware parameters. So in order to engage with these potential users, we will organize events such as workshops, brainstorms, and hackathons. And at these hackathons, the participants can work on challenges and, for instance, use the Quantum Network Explorer, which is our simulation toolkit containing different software packages, which is also available to the public via web platform. It already contains ready-to-go applications so that participants and users can already start at a relatively easy level. For instance, by simulating entanglement rates over separate links with different fidelities. So finally, I would like to draw your attention to the next upcoming hackathon, which will be organized by RIPE in collaboration with a couple of partners, among others, SURF and Kia and Géant. The hackathon will be from 1 to 2 December in different places in Europe, among others in Amsterdam. And if you're interested, look at the website of RIPE Labs. And I want to conclude this lightning talk with thanking RIPE and Vesna Manojlovic by being so cooperative in organizing this hackathon and giving me the opportunity to present our ideas with you, and hope to meet and engage with you in the future. Thank you.
Okay, thank you very much. Do we have any questions for this one? Because in the Q&A, I don't see anything new.
Sorry, I'm not a technical person, first of all.
Please
So I'm
state your name and affiliation at the
sorry.
microphone.
Lujan Larus Limited. I'm not a technician, and I might ask a very stupid question. Would that be significant performance improvement in terms of quantum internet?
Repeat the question. I can't really.
Will that be significant performance improvement in terms of quantum computing compared to current internet? Because I read all this entanglement between
Please keep it short. It's a lightning talk, and we need to. So did you have something to reply? Maybe a quick answer.
Sorry, can I finish my sentence, please? Just a second.
You are.
Yes, I heard all this quantum entanglement and all that, and it seems this came above the light speed, and the light speed essentially is the limited speed limit for the current internet.
This is a very fundamental discussion. I cannot really comment on it, but what the specialist ensured to me that there is no communication faster than light speed, because the entanglement also has to build up. This is what I can say. What a specialist told me. You're really bright people.
Okay, thank you.
Yeah.
Okay, thank you very much.
Thank you very much. It's our second quantum-related event. So our next speaker is virtually present. His name is Oleg Basistri, and he is presenting about VPN generator. Okay, you're on screen, so please speak up. Thank you.
Thank you so much. It's really awesome that you guys are talking here about the future of internet. Even so, it's so amazing as quantum internet. But I'm afraid I'm going to have to take you a little bit to the reality we're facing right now. Honestly, I cannot see what's on the screen, what is being presented. Is anything being presented at all?
We see your video. And you can switch it in your mic taco to be sharing. And now we see your slide deck.
Awesome. Yes, thank you. What we're going to talk today is about freedom of the internet and the recent events concerning Russia and Ukraine that eventually made us to do what we are going to do today. So this is going to be a lightning talk indeed. My name is Oleg Basistri. I am COO of VPN Generator. And basically what we are is a group of people who left Russia after the war began, who decided that that war is not usually won by weapons. And we actually can do a lot by working with the people inside Russia. And after we will manage the problems with Russian, we can scale this idea to the whole world. At this moment, you might be thinking, oh my God, this is 2022 and somebody is still talking about VPN as something new. Yes, that's our thoughts exactly. That's why we came up with something a little bit different. You see, Russia is now one of the most experienced countries in terms of censorship and blocking, and it's very easy for it to block, for example, commercial VPNs. We see them blocked in packs like every week or two. And there are amazing solutions like Siphon and Lantern that are working hard day to day to find new ways, new backdoors to sneak in some traffic into the oppressed countries. And we would not even think of challenging them. So we came up with an idea that maybe we could actually walk a different path, a more decentralized path, that might allow us to sneak beneath the radar of heavily centralized entities like Roskomnadzor in Russia or any other censorship authority in any country. So what we came up with, you see, we might as well create a lot of VPNs that would look just like any usual corporate VPN of a small business. that is tremendously hard to block, not because it's difficult, it's because there are too many of them, and blocking all of them would cost way much more than trying to block Lantern, for example, or any other centralized VPN that has a central point that can be targeted and blocked. So what we are doing right now, we are creating an MVP version of this product that is going to be distributed absolutely freely among the people of first Russia, the first target audience, and then, I hope, around the globe. And by the end of the year, we expect to have 100,000 people connected to the system, generating 1,000, well, more or less 1,000 of small VPNs that are going to work separately and ain't going to be connected to the to each other in any way that is possible to monitor. But well, that's the point. So basically, we are doing a lot of small VPNs that are easy to manage, and the main way of distribution of it is via friends and family. So we just have to have one person that is more or less interested in IT and have read the news about us. He downloads the thing and then starts sharing with people around them. Simple, easy, and it seems it might just get through the bubble of oppositionally minded people, because everybody wants to go to Instagram, which is blocked in Russia or somewhere else. But another part of this conversation is what we need. Basically, we have one idea right now that is mainly should be focused on here, is this RFC captive portal number 8952, which specifically says that to maximize universality and adoption, solutions must not be specific to any particular SS technology. And obviously, it has been told about the ways to connect the internet. But the thing is that in the world where countries the size of continent consider VPN as an SS technology, billions of people in other countries are using VPN day to day to work, to study, to live. VPN is an SS technology at this at 2022. So what we would be working on, except for the product itself, is to either create a new RFC or make an addition to it, to make a VPN NSS technology to ensure the possibility to use captive portals on it, to provide information how to use it via this captive portal. When we are going to motion for it, I honestly hope that you guys would be able to support us on that. Obviously, as any non-profit organization, and we are serious about going non-profit with this, even though like most of the team on the back of it have business experience, we are absolutely positive that this project specifically should stay non-profit. You know, like state medicine, everybody got to be saved. So what we were gonna need anyways is IP addresses, obviously. Then we were gonna have to we will be looking for hardware and virtual machines and stuff. Of course, we would need money. And what is most interesting is partnership in tech, both in big and small. This we're gonna talk a little bit later about, because this is another thing that we are looking for right here. Everything else, honestly, we're gonna get, because the product itself seems to be kind of an easy win in terms of acquiring the market share. As a product manager myself, it's kind of obvious to me. But we are not struggling only against the environment. Yeah, we are struggling against the pretty specific people working in offices and in pretty very big countries that are willing to spend money on censorship. So we have to think what's going to happen next. What's going to happen if all the VPN protocols, for example, in Russia or in any other country like, I don't know, Iran, are going to be blocked? What we're going to do next? So Basically, the guys can block everything. They can block, create the whitelists for VPNs, which is kind of a solution to get rid of, well, to beat us on some level. Or maybe there is even an idea of a VPN tax to make a specific list of people who are using VPNs. Those solutions are possible, and we are working to overcome them. Well, basically the whole world does. So there are different RFCs that are on the way to already approved for fighting censorship. It's obviously DNS over HTTPS. You know about this, I presume. Also, there is encrypted client hello and quick and the mask solutions. I honestly hope that you guys might as well root for them on the when you have the chance. But still, those solutions are not well, kind of also easy to block in one way, and on the other way are not yet adopted. So praying on something to happen is not our way. We prefer to act. So another idea is that we might jump to such a thing called reflection networking. What is it all about? Well, what happens if you find enough partners, both in big and small technology companies, that would be able to refract a little bit of traffic from the known reachable website from the oppressed country to a blocked one. This way, we would be able to increase the stakes of blocking of for sensors on up to the level of closing the whole internet for the country, which costs like a lot. And in my and I hope that if we will be able to find those partners to find companies that are gonna reflect some traffic for us, we would be able to increase the sustainability of our project even further. So these are the ideas that I came with today. Might as well we might as well jump to questions, I presume. Thank you so much.
All right, thank you. Like we are a bit shorter on time than we should be, so I guess I get a couple of people saying what they want to ask you. Hey guys, I think I have to close this queue. We still have one more speaker. Please go ahead. You state your name and say that.
Yeah, thank you. Vladislav Olopian from the Global AI Foundation. We had experience with some internet censorships in different countries 2 years ago when the pandemic began, and some of our employees got stuck in their vacation countries or somewhere and could not return back to Germany because of travel limitations, and they had to work, but they couldn't because VPN didn't work. And
did we lose our speaker? Because
I'm here.
Okay, you're still there. Then it's fine. Sorry to interrupt you. Could you wrap up your question, please?
Yeah. So the question is, much of countries with internet censorship that I observed, they don't ban specific IPs or subnets or specific services. They ban protocols using deep packet inspection. And if some foreign network operators help to
please.
Yeah.
Sorry.
Excuse me. Yeah. If some network operators try to help to get over this ban, they ban the whole subnets or autonomous systems. So how do you propose to work with this? Thank you.
Work with what exactly?
Sorry, maybe you guys can have this discussion offline. We are like really running out of time. I'm sorry.
Yeah, okay, ma'am,
if you
I will show the presentation for 1 second to, if I could, can I do this? To show my contacts, if it's possible, so we could continue the conversation. So you can contact me via Okay. Well, via email or via Telegram, I will. Please write something in chat. I'll contact you. Okay. So thank you.
Okay, thank you.
Yeah.
So we have one more speaker on the microphone. Sorry, the queue was already cut.
No, I come first.
No, we cut the queue after him.
I was here first.
Okay, then please do go ahead.
Well, I run a large VPN network to pass the censorship many years ago. So this is essentially trying to solve a political problem with a technical solution. So that here is my quick question. I know everybody running out of time. Is number one, do you consider the diversity and branding of your solutions? Because in terms of censorship, if you have one single brand, one single website, and one single solution, it's very easy for the political body to block you. And then there's another effort which you might consider to do is large amount of content, which is a blog, is not a political related topic. Like for example, Google academics, the research papers. And do you have a plan to make those cache available locally in the country where there's censorship, so it's non-political related, so it's easy to catch it locally, but most of the times it will become the casual damage. So getting over censorship is a one big topic, and it's require a lot of solutions, and we get around it. Technical problem essentially is short-term solution. I think the ultimate goal is that non-political related content like research paper and others humanitarian stuff related should get through the censorship, have content I catch locally. That's probably the ultimate solution than fighting the political body directly with a technical solution, which always a cat and mouse game.
Please wrap up your question.
Yes, that's it.
Okay, so definitely there are a lot of yeah, very quick. There are a lot of ways to fight the censorship. Yours one also may exist, and if you would be able to make such a thing, it would be awesome. We would partner with you, we'll be friends. Well, so I encourage you a lot to do this. That's awesome.
So one last, please be brief. I'm sorry.
Since there was no technical solution in your presentation, I didn't get your solution at all. But having a lot of IPs is not a solution, because usually we see that they block the protocols and they see the patterns and the traffics that are, for example, equal, and also they can filter all of IPs. And as you can see in Iran right now, for example, if you see the traffic of some big data centers, they face a huge decrease of traffic from Iran. And also, we have a lot of free VPN connections that goes through some people's network that it's not secure. It increases the security risk because they can see the traffic, they can inject some certificates, and etc. Thank you.
Okay, so basically, yes, the blocking goes through protocols, and that is why our solution seems to be about greater collateral damage, what I was trying to show at the very beginning. What's the idea? Right now, the governments are trying to fight the specific companies, basically. So the websites, the domain names, something else, yes? And out here, when we are using just something looking exactly like another WireGuard or I don't know, IPsec personal VPN, you're gonna have to block it all, including, I don't know, if you're talking about Iran, I don't know, the nuclear program VPN and something else and something else and something else. The collateral damage of it is exceedingly high, at least for the time being, until they're not those countries are not totally blocked by the economy. So in my perspective, our solution is exactly about making them pay more to achieve the same. Pay so much more that they won't be able to do it at all.
Okay, thank you very much. And thanks for the great presentation. You clearly gave us a good base for discussion, so everyone knows how to reach him. And thanks for joining us remotely on this meeting.
Thank you so much, guys.
Bye.
See you.
Our next speaker is Massimo, and we'll talk about RPKI and BGP monitoring.
So this time I got one of the last presentation in the last slot of the RIPE meeting, and I'm going to help and make it really quick. And also because I know that together we sure that it's going to do the technical report later. We are keeping you away from a working group that cannot be mentioned and that doesn't exist. And super fast, I'm going to talk about, I'm going to explain you how you run out of excuses and it's time for you to monitor about your BGP and RPKI operation. My name is Massimo Candela. I work at NTT. I'm a senior software engineer at NTT. This is a picture of our global IP network. We are a tier 1 and a large network. We need software to control it. And among these softwares, in 2019, I developed a tool called BGP Alerter for BGP and RPKI monitoring. It's a tool that you can download and run. And basically, you can monitor your autonomous system from hundreds of vantage points distributed in the world, get informed about hijack, loss of visibility, if one of your peer appears out of the blue, RPKI invalids, and various other things we will see in a bit. And you can receive these alerts wherever you want on emails, Slack, Telegram, whatever. I developed it for NTT, inside NTT. After we decided to open source it, it is kind of a success story because now we have hundreds of installations worldwide. Well, we have people install it worldwide, and there are some important also operators that they use it in production. So this is actually pretty good. And the idea behind releasing it open source was that more operators would probably monitor if they would have a tool like this, and we will all achieve a more stable internet. We will also benefit out of it as a tier 1, but everybody could benefit out of it. But however, then while the number of people monitoring is increasing, the need for monitoring is never ending. And last year, last RIPE meeting, I show how, for example, there are autonomous systems that they announce RPKI invalid for wrong max length for months before they do something about it. So, but what's new about this? Well, what's new is packetvis.com. So as you see, there is a balloon. 10 years ago, when I started doing presentation at RIPE meeting, I thought it was fun to put a balloon when I present something new. Now I'm a bit stuck with this. But anyway, this is a balloon moment. Packetvis.com is a BGP alerter as a service. It's not an entity product or an entity service. It's run as a personal initiative. Basically, you go on this website, packetvis.com. There is a red button that says start monitoring. You click there and it shows you this box where you put your autonomous system number. And after, once you have the autonomous system number, we do the entire configurations and everything for you. And in addition to, and at some point we start monitoring, we notify you, we are monitoring. And there is a page where you will start receiving all your notifications. So basically you have a list of all the events, for example, hijacks that they happen. So in addition to the usual email and Slack, you have this page. When you click on one of those events, you enter in the page related to the event. In this case, is a hijack. So you have the usual summary, but also a more enriched, more data that you can see, so they can help you with the troubleshooting. But in particular, important is this actions panel at the bottom. That, for example, this is a hijack, but the actions panel says, is this autonomous system allowed to do that, to announce this prefix? If you say yes, it is allowed. From that moment on, the system, Packetvis, will not alert you anymore about that. So basically, over time, by acting on these alerts, you will make the system more silent and more suited for your type of monitoring. There is a page where you can go and set the type of alerts. There are 11 type of alerts inherited from the BGP alerter. So hijack visibility, you have, for example, RPKI invalid when your ROAs are expiring, monitoring upstream and downstream IS to check if they are the one that you configure they should be. And you can configure this both at global level, then a single prefix level. There is also this page where you can integrate it with other stuff in addition to the email, which is by default. You can use PagerDuty, Telegram, Slack, syslog, whatever you want with this interface. And of course, if you want to go classic, there is a REST API that you can go and query and integrate with your Nagios and get the alerts out of there. And there are some more advanced things to filter by severity and stuff like this. So my presentation is over. I made it really quick. I hope you appreciate that. And I don't think there is time for questions. But anyway, you have my contact and you can email me and you can go try. And especially last one thing, I'm expecting feedback. So please let me know how we can improve it to make it really suited for your use case. Thank you very much. Thank you for the attention.
Thanks a lot, Massimo. I think this is a tool every BGP operator should use. Oh, we don't have time for questions, I think, but Therese Francisca with a little announcement.
Exactly. There's one thing that the PC still has to do before we hand over to the tech report. I am happy to announce that Antonio Prado and Moin Rahman will join the PC for the next RIPE meeting. So looking forward to work with you.
So, ready?
Yeah.
Okay, I'll keep this brief as well. Welcome to the technical report. I've got some statistics for you about what we've been up to this meeting. The main thing that has actually changed for everybody is that the main Wi-Fi changed and that it's now IPv6 mostly. Depending on your machine, or basically the version of your operating system, you will get IPv6 only if it's sort of modern. You can still get dual stack if you want it. And Ondřej, who's at the tech desk now, did a lot of work on this, so I think that's very great. We've had about 60% IPv6 only and 40% dual stack. And unless anybody is going to speak up in the questions, I think it went pretty smoothly. Also, 2.4 gigahertz seems to finally be dying out, probably except for microphones and things like that. I can't even use my own clicker. That's the network we built up. We got a 2 LACP but 10 gig lines from SOX. They wanted to offer us 100 gig, but we didn't have the equipment, so we went with 10 gigs. And actually, 10 gig is plenty as well. As you can see from this slide, I mean, you guys only went up to like maybe 300 Mbit on a good day. The green stuff here is IPv6, by the way, and the red stuff is, of course, bad. That's IPv4. So this is the Wi-Fi network layout that we've put together. This is Menno, and as you can see, he's like very strategically placing all the access points on the floor and making a little map with tape. And then he actually put them in the building and on the map. And yeah, we've gone with fewer access points than we did in the past. I think it's actually more stable that way. So looks good as well to me. The Meet Echo stats, they're not very pretty, I admit, but I was in a rush. So the interesting thing here, I think, is that if you look at the percentage joined over IPv6, it's actually higher. I'm not sure whether that's up to Ondřej's good work with, you know, getting more people onto V6 on the Wi-Fi, and then they basically join to Meet Echo from here over IPv6, which is sort of cheating. But I'm just gonna, you know, think to myself that there's actually more people having IPv6 at home, because you can dream, right? So normally I would have coffee statistics here, but the barista got COVID. So instead I have music stats for you. You know that Happy French tune, right? We looked it up, and apparently on one we have 4 Macs in our setup, 2 in each room, and only one of them has played it already 4,000 times since we got it, for a grand total of about 16,000 times Happy French Jazz. So if you want to play it at home because you just can't get it out of your head, that's the URL where you can get it. And you can find the slides online, of course. The only issues that we've had is when we got here, there was a wedding happening on Saturday night. And yeah, the AV guys really pulled it all together. So thanks very much. They worked the half night through together with the hotel to clean everything up, set up almost everything. And when we got here Sunday morning very early, most of it was just as it should be. The only other hiccup network-wise is that the access points in the lobby went down at some point because the wires are in the baggage storage area, and yeah, packets are limited to 45 degrees, and that picture is basically what we found. So a bag killed your internet. Then when I got to the side room after the whiskey boff, my tables had been stolen. So I got them back, but you know, I mean, it was interesting. And yeah, you know, I really have to thank the tech team. I mean, I think we made a great meeting, and I hope you all agree. If you don't agree, they have been working on basically alternative careers. You know, we have, you know, they're trying to make sure that they have an income after this meeting. Of course, also we need to thank the web team, the Meet Echo, I don't know where they are, the Meet Echo team, and of course the stenography team. And I think that's it.
Thank you very much. And I love the IPv6 preference. Can I say it again? I love the IPv6 preference. Please, that question. I'm also monitoring tech show Q&A, maybe. Okay, 2. Go ahead and ask that.
Hi, I'm Will. I'm internet user. Thank you very much to the technical team, Steno and Meetecho. That was amazing. Just a really short one. You might want to go and look at the hotel Wi-Fi router at the port 8080, because there is the graph of the traffic that was used for the hotel, and it seems weird that we had some spike of traffic in Wednesday evening, around 10.
When tables got moved, you mean?
Mm-hmm.
When the tables got moved somewhere else for some reason.
Something like that, yeah. Thank you again.
Can I be heard? Yeah, great job with IPv6 mostly.
Please state your name.
Yeah, so I think it was great that this was set up here to get also some information how that works in practice. I have a question about the IPv6, IPv4 stats. So is that IPv4 that goes from RIPE meeting out, or is that also things that go to NAT64? So is it internal IPv6 or what goes out?
I'm pretty sure it's only the external line that I'm showing here.
Okay. Would it be possible at some point also to get numerical how much IPv4 it was?
Yeah.
Offline.
I've got it for you if you want it. Drop me your email address or just email me at that, and I'll get it to you.
Okay, perfect. Thank you.
All right.
Thanks. We actually missed one remote question from the previous session. I read it, but don't expect it to be answered. How often are the prefix lists for the SN refreshed in packetviz, or should you add it manually? Well, it's for the previous speaker, so. Okay, please go ahead, Ondřej.
Ondřej, South Caribbean CC, I have just a small remark. There is some rumor surrounding this RIPE NCC chat that for this airport in this city, you need to print it boarding pass. So I would like to remind you that there is still printer at the registration desk, which is called terminal room printer. So you can use it to print your boarding pass, but do it before lunch, because after lunch the network will be offline and the printer will be gone.
Yep.
There's also a hotel printer, by the way. So
yeah, there's a little business center here next to the reception that has a printer as well. All right.
All right. We are good with the questions.
So then onward. Thank you again, your technical team. You're wonderful. Thank you.
And with that, we happily hand over to the chair team for the closing. I would like to remind you to please rate the talks for the entire meeting. The PC really appreciates your feedback on what we did here. So now, Miriam, your turn. And Neil, obviously.
Thank you. Thanks, Franziska and Dimitri and the whole PC. I think you did a fantastic job. Try to be quick because this seems to be the theme for this afternoon or this morning, to be quick. I know. Right, so just a few statistics that the RAP NCC meeting team has put together here for me. So we had totally checked in attendees, so not registered, but actually really checked in 748, of which 493 on site and 255 online. About 350 participants were on average on Meteco, you already saw that. 202 newcomers, which is great, it's a high number. Yes, good, yes, I'm also really happy to see the high number. And we had 6 children here in childcare on site, which is also a high number, and 14 online. Yeah, somebody was asking yesterday, I think, about what does that mean in online childcare. But I think we started this during the pandemic, that we actually have a company who does kind of some online coding for kids, which is really cool. I want to participate in that as well. Yeah, I'm really happy we were able to provide childcare again. I just want to add also a report here from the trusted contacts that actually we have a slide for that. No, did we add that at the end? No, oops. I think we have a slide on that. I don't know why it's still on there. Remind me if I forget. This is just the participation across countries online. God, this is, did I skip one? Yes, let's go first on site. So still we see a lot of high numbers from Germany and the Netherlands as usual, if you will, but also of course in a high number from Serbia. Also again, a lot of, you just see a lot of different participants from different countries here at this meeting, which is great. For online, quite similar. Though we see a very high number from Ukraine also participating, not only here on site, but also remotely. There's one new activity that the RIPE community has started, and that's a new task force that was agreed yesterday during the community plenary that we'll set up. It's an initiative by the DNS working group, the cooperation working group, and the BCOP task force has offered them help. And the goal is to draw up some guidelines for running a public resolver, DNS resolver. And there will be more information sent to the RIPE list and to the relevant working group lists there as well. So you'll find out more if you're interested. Talk to the DNS working group chairs or the cooperation working group chairs. We also had NRO, so the Numbers Council elections for the Number Resource Organization going on. There was one seat became available after James Kennedy filled like the last term, for only a year, and so there were 2 candidates, and the elections came out with James Kennedy as a next member for a. I don't know if he's here. Oh, there he is. Hi, James. So now James will start a full 3-year term on the IC elections. Congratulations. We have one outgoing working group chair, that's Shane Kerr from the DNS working group. Bye-bye, Shane, and thank you very much for the good work. Instead of Shane, we have Willem Torup, who will be the new co-chair for the DNS working group. Welcome, Willem. I don't know, are you here? Are you still? Some have already left. But and then we also had 2 terms renewed for Rob Evans in the RIPE NCC services and for Raymond Yetten in IPv6. They were standing again. Their term ended. They were standing again, and they were selected again by their working groups. So this is the whole set of working group chairs for now, just so it give you an overview. I'm not going to go through all of them here. And of course, we have the the old PC, obviously, because they did all the work for this meeting. So the two outgoing members are still on this slide. And thank you very much for a great program that you've put together here. I thought we had some gifts for you. I don't know, Alex, are you around? Can I ask the PC members that are here in the room, who are here in the room, to come up, stand here with me for a short while, and so we can give you a token of appreciation from this
Thank you very much.
meeting team and the web chair team. Is it? Oh, but Peter has. Yeah. This slide is actually not correct. This is Max. This is not Peter. So sorry about this. Somehow we got mixed up there at the last minute. It's always a kind of last minute changes. Sorry about this. So thank you guys. And then for next time we'll have two new members. So special thanks to those two who are going out at this RIPE meeting. And these are the two new members that have been elected that Franziska has already announced. You have a question, Sander?
I just want to, Sander Stefan, just want to make a comment on the working group chairs, because I heard some people comment like, well, sometimes there's only one candidate available, so there's not much of a choice. So this is by design, because running a working group is hard. So often, if people are happy with the current working group chair, they often get reselected. But I do want to remind everybody that everybody is welcome to become a working group chair. So also newcomers, doesn't matter how often you attended. So I just want to make it clear that this is really something run by the community. So if you feel like it, please step up.
Yeah, thanks for the reminder, Sander. That's absolutely true. And while I think the working groups, we're of course, happy with the current chairs and select the outgoing chairs or the incumbent co-chairs. And I'm really glad that Ray and Rob are running again. It's definitely also good to get new blood into the team, and I would like to encourage you to all think about in the working groups that you're active in. Maybe next time a term comes around, you would like to participate more actively and take on a role as a co-chair. I do remember now that Olga, who prepared these slides for me, actually put the trusted contacts reports kind of there on as a reminder. So I just wanted to go back and tell you what I've heard from the trusted contacts team during the week. They have received 2 reports. One report was submitted by email, but the person has decided to take it elsewhere, and there was no further action required from the trusted contact team. And then there was one other report in person, and that has also been resolved directly and internally. So it was a relatively quiet meeting for the trusted contacts, they said, which is, I hope, good news, but I also hope that people feel encouraged to report things to the trusted contacts if something goes wrong. Right, then we come back to more prizes and winners here. These are the prizes for the presentations. So these were the presentations that rated the highest. I don't know, Alex, help me out here. Do we congratulate them? And they will be sent something, I think. Yes, the event, see, I have all the notes here. I don't know why I'm struggling. The events team will contact you and get your details and will send you your gifts. That's what I'm supposed to say. And the same for you. There's also a prize for the newcomers on-site registration raffle. That's Eric West. Again, we'll contact you. You don't have to come up here now. And for the online and for the on-site raffles, there are 2 different people, Eric West, Thomas Curley. And there's a Kahoot winner, Robert Check. I think he's actually participating online, and he won the Kahoot. Well, you can, of course, participate in Kahoot both online and on-site. So congratulations to you all. And yes, congratulations. It's always fun to have winners. Last but not least, share your feedback with us, please. Here's the QR code and also the feedback form. I gathered a lot of feedback already during the week, but I would really like to hear from you. The feedback form, covers all kinds of topics, venue, and the meeting overall. So that would be really helpful for us. And now, really, last but not least, I would like to thank specifically the two hosts. Can you please come up here? Do we have a representative here from SOX and from RNIDS to come up? And I believe Alex has also a gift for you. And you've done a fantastic job in hosting us here. And specifically, the party last night was a real success. I really enjoyed it. And I think many of us did. And of course, also thanks to all the other sponsors who made this possible here. And this is a bonus slide of the beautiful photo of the tech team that Short has just represented here on stage, just to show you a more serious picture. And oops, I hope to see you all. Did I jump again? Oh my goodness. No, this is good. This is the next. But you're probably right. I should show this first because somebody has asked for a specific lightning talk. I just want to remind you that all the videos and all the talks are archived, and they are in the Vibe meeting archives. And this specific video has been requested during the week, and that's actually a presentation by the stenographers who have explained how they're doing this. And it's really interesting, and it came up in a couple of sessions. So here's the link. You can find it. You can find it there. And yeah, see you all hopefully next time in Rotterdam. Been there before. We're going back. It's an improved venue, improved hotel. So hopefully I'll see many of you there. And just in case you have anything, you talk to me or Neil directly, here are our contact details. That's all from me, and that's adjourning the RIPE 85 RIPE meeting here in Serbia. I had a wonderful time. Thank you all.
Thank you, Chair. And what is happening? Who are these people? What are they going to do?
I don't know what's happening. So you tell me. I can start. Dobar dan. But my Serbian is really crap. Jan, you're somewhat more local than I am. Can you do this? Because
okay. Tajna radna grupa. RIPE 85 Beograd. Odnos. To je komplikovano.
Please turn off the encryption. We just got given the slide, so I don't know. Let's see. Let's just keep going.
Nemojte raditi slika i nema videa. Nemojte staviti ništa na Facebook. Nemojte na Twitter. Što je ovo, Instagram? Ni Instagram ne može. Snapchat ne može. Šta je već ovo? Ne može nikako. A pogotovo nemojte staviti ništa na Splat.
Okay. Let me go back a slide. So let me see if I can actually fix this. Language. Let me see. Look at that. Here we go. Brilliant. Let me try this. So welcome to the Secret Working Group, RIPE 85 in Belgrade. Relationship status. It's complicated. So welcome. And in case you didn't know, the Secret Working Group has a subscription program that gives you an ad-free experience. But since none of you subscribed, yeah, well, I'm sorry.
Sve što poželiš, suši ili burger, naruči Glovo. Treba ti nešto iz prodavnice, naruči Glovo. Niko ne želi da ide po pivo, naruči Glovo. I preuzmi zasluge. Skini aplikaciju i kad želiš bilo šta, isporučeno brzo. Naruči Glovo.
You know what it is with this ad localization, and I mean, you can't even click through them anymore. So yeah, I'm sorry. There's probably going to be a few of them in there. So the Secret Working Group. That means no pictures, no Facebook, no Twitter, no Instagram, no Snapchat, no WhatsApp. I'm starting to realize that this slide is getting outdated. And also no Splat.
I told them already.
You kind of did. Maybe. I might not have been paying attention. I'm sorry. And what is Splat, you ask? Now that is a secret, but not for much longer. Watch the next Secret Working Group presentation in Rotterdam. So what is the Secret Working Group? And we thought the most fitting way to describe the Secret Working Group is by a sonnet. So Nigel, as our resident Englishman, please take it away. Here we go.
Ripe is, of course, a sober set of folk, except for Thursday night, when things might slip, and serious work can frown upon a joke, with working group to hardly ply the whip. We need a safety valve, lest pressures rise, a space where rules relax a tiny bit, where mischief raises laughter to the skies, and stolid arguments give way to wit. And so, the Secret Working Group was born, a means of gently raising smiles and fun, and sometimes take the chance to gently warn that true respect is often hardly won. It isn't just a set of funny slides. Within, a grain of truth quite often hides.
So, about that relationship status, the unspeakable happened yesterday at 4 o'clock, actually closer to 5, where the community plenary discussed the Secret Working Group. And more shockingly, someone on the spot created a limerick about it. So I will now invite Mr. Rick Nelson to read the limerick that he created for the occasion.
On Thursday's plenary community, much was discussed on unity. Our secret group was outed, but no one Foster shouted, and we need new folks for continuity.
So here's another thing about that unspeakable event. And I don't think many of you realized this point, because it is somewhat buried in the old RIPE documents, which is, how do RIPE working groups get created? They get discussed in the plenary, and when consensus is reached, you have a working group. So as a result of yesterday's events, according to policy, the Secret Working Group is now an official and public working group of the RIPE community. And that's why we think this is a complicated relationship. It's complicated. So hey, here's some local wisdom. Stop trying to make everyone happy. What can I say? Meanwhile, on the internet, weird things happen, but I mean, I shouldn't be telling you this. You've all been there. Here's we could tell you, but we'd have to sue you. Now, things you don't expect. Here we go. So it was brought to our attention that there's this cartoon that you can now watch on Netflix. And it is called Bee and Puppy Cat. For me, that's all I need to know about it, really. But it was the attention of the secret working group was raised to a scene out of season 1, episode 8, in case you're go looking for it. And here's a screenshot of it. Which is the ARIN RPKI tell, which you are not allowed under any circumstances to redistribute without a signed agreement from ARIN. So, of course, the secret working group, being the rule observing people that we are, I blocked it out. But I mean, if you go looking for it, I mean, you're really desperate, go watch Netflix, I guess. Now, furthermore, I mean, so the secret working group, even again yesterday, got accused of doing stuff in smoke-filled back rooms, right? And so we thought, for the sake of inclusiveness and transparency, we decided to do you all a favor, and so we filled the entire hotel with smoke this time around. I hope this makes you happy and feel more included in all of this. Then on to some logistics issues. There was a bit about a bell, I guess.
Calamity struck right away. The interval bell went astray. A hasty replacement was found in the basement. It was rung, and the sound saved the day.
And here we have our fearless board member Piotr demonstrating the replacement bell. Now, what else is here? So this meeting room. I mean, I'd like to refer to the people over there and over there as the remote participants of this session. And we thought it fitting that we now have some. I think I counted 9 screens to just be able to look at what's going on here. So we thought,
and
actually,
different time zones.
And 2 different time zones. So I thought, you know what? Maybe we could do a better job if we changed the aspect ratio of the slide. So, I mean, this is a bit of an experiment. Here we go.
The room was a tiny bit wide, a light year or 2 side to side. Lorentzian lag was a bit of a snag, and there caused some delay to its slides.
So I'll wait for the joke to end up over on that side. Why am I? Okay, here we go. Sorry.
Nobody subscribed.
In this busy world, we're always doing 2 things at once. So Lysol combined cleaning and disinfecting into one convenient wipe to clean messes and kill 99.9% of germs. At the same time. This may take some getting used to. 1 wipe, 2 jobs.
You get the weirdest commercials when you're watching this stuff online. I don't know. On to the end of the internet. I think, Jan, you have something to say about that.
The barista was lost with the bell.
Yes.
So the coffee was iffy as well. By the end of the break, with no coffee or cake, the internet's going to hell.
So, coincidentally, when I was here last year presenting at RSNOC, who graciously invited me over, I was given a mug, a coffee mug, and this very adequately reflects this issue. So this is a picture of the mug. Again, thank you to the RSNOC organizers. This is a lovely gift. Right, what else do we need to talk about? Yeah, we had some submissions about the dinner. So I guess we're going to have to bring that up a little bit. Here we go. This is a goat rodeo.
A goat rodeo. It's not much of a rodeo, is it?
Oh, no, yeah, fine, whatever.
After the meeting with too many votes, the jazz band had played us some notes. The buses were tardy, the food a touch lardy, and the wine was fermented red goats. It actually says 3 red goats.
Okay, and so out of all of the submissions that the secret working group received from people, this one got submitted multiple times, so I felt obliged to include it.
The most popular one.
Yes. You know, with that, I think I'm about to run away from stage. I do think we're done here, and well, the next meeting is Rotterdam. So Rotterdam, yes, Rotterdam. Yeah, Rotterdam.